What is trigonometry? This will be an introduction to right triangle trigonometry. In this video, I'll give you an overview of trigonometry. We'll review back onto the roof task. We'll briefly review naming ratios, and then I'll show you how to use a trig table to solve for missing sides and missing angles. I'll discuss some common mistakes, and you'll summarize. The Wikipedia definition of trigonometry breaks it down into the two roots of the word, the one that means triangle and the one that means measure. So we're discussing the relationships between the lengths and angles of triangles. We'll begin by focusing just on right triangle trigonometry. Right triangle trigonometry is an extension of similar triangles, like we discussed in our warm-up a few days ago. If two right triangles have a second pair of angles congruent, for example, if they both have a 14-degree angle, the triangles are similar by angle-angle. Therefore, knowing that the sides are proportional, we can solve for unknowns if you have information in one triangle. For example, many of you used scaled models to find the ratios of the sides in the roof task. By creating similar triangles, you could solve for an unknown. Here's another example of similar triangles. In this case, these triangles have angles of 30 degrees and 60 degrees. And for example, if this side is 1, this side will be 2, and that ratio will hold in every right triangle that has a 60-degree angle. This side would be 2, and this side would be 4. This side would be 3, and this side would be 6. The same relationship between those two sides would hold. We discussed this in class, that there are 6 ratios that can be made out of the 3 sides of a right triangle. Please memorize these 6 names and their abbreviations: sine, cosine, tangent, cosecant, secant, cotangent. And here's our symbol theta, representing an unknown angle. A trig table is a tool that shortens our processes a little bit. So when we did the roof task, you had to draw your own similar triangle to find the ratios between the sides. A trig table has already done all those calculations for you. So for example, if you had a triangle with a 10-degree angle, the ratio of its opposite and hypotenuse sides would be 0.1736. Let's take a look at some examples using the trig table. So on our roof task, we were solving for a missing side. The information we had was a 14-degree angle, and we knew that this side was 20, and we were solving for this side. Well, we knew the adjacent side, so if this is my angle theta, we have adjacent, hypotenuse, opposite. We knew the adjacent side, and we were looking for, or needed, the opposite side. Opposite and adjacent make the tangent ratio, usually shown as tangent of theta equals the opposite over adjacent side. So in this case, we know what theta is. We know that theta is 14 degrees, and we know that the opposite was letter B, and the adjacent was 20 feet. Looking it up on our trig table, we would be able to see that the tangent of 14 degrees is 0.2493. By cross-multiplying, I can solve for B. And we get approximately 5 when I multiply these two, equal to B, and there's my final answer. Going the other way, if you were told this side length was 5, and this side length was 20, the two sides that we have are still opposite and adjacent, which still means we're looking at the tangent ratio. So once again, we can say the tangent of theta is equal to the opposite side over the adjacent side. In this case, we don't know theta, but we do know the opposite, and we know the adjacent. If I get a decimal approximation of that fraction, in this case it's a pretty easy one, 0.25, I'm going to go back a few slides to look at the trig table and see if we can find where tangent is closest to 0.25. Looking at the trig table, going down the tangent row, we can see we get closest to 0.25 here at 14 degrees, which confirms what we already knew. So, some common mistakes that I'd like you to avoid would be labeling the triangle wrong, which would give you the wrong ratio. Even when you turn the triangle upside down, we can still label opposite, adjacent, and hypotenuse. The two sides that make up the angle will be adjacent and hypotenuse. Hypotenuse is across from the right angle, making the other one the adjacent. And then our third side would be opposite. And then solving for the proportion wrong sometimes happens when you're solving for the number that's in the denominator. Make sure you use cross multiplication if it's easier. Don't forget to summarize, perhaps explaining what right triangle trigonometry is an extension of, what are the names of the 6 ratios, and maybe mentioning the 2 common mistakes.